Hi, dear students. Today, again, we are going to discuss Module 1. So, this is fourth video lecture on Module 1 of Data Mining and Data Warehousing. So, in this video lecture, we are going to study schemas for multidimensional data models. So, in this schemas for multidimensional data models, we will study star schema, snowflake schema and fact constellation. Okay, so all these three models are multidimensional data models. Okay, the entity relationship data model is commonly used in design of relational databases. So whenever we are designing a relational database, we are using entity relationship data model. So in entity relationship data model, where a database schema consists of a set of entities and relationship between them. So entity relationship data model is appropriate for online transaction processing. A data warehouse, however, requires a concise, subject-oriented schema that facilitates online data analysis. So entity relationship data model is useful for development of relational databases, which is very appropriate model for online transaction processing. But we are dealing with online analytical processing. So in this case, we require a data warehouse which should be a concise, a subject oriented, and that facilitates online data analysis. The most popular data model for a data warehouse is multidimensional model. So multidimensional data model is the most popular data model for a data warehouse, which can exist in the form of either star schema or as in the form of a snowflake schema or a fact constellation schema. Okay, so schemas for multidimensional data models, there are three schemas available. One is star schema, other is snowflake schema and fact constellation. Star schema, a fact table in the middle connected to a set of dimension tables. So in star schema, we will be having a fact table which is connected to a set of dimension tables. Now snowflake schema, a snowflake schema is a refinement of star schema where some dimensional hierarchy is normalized into a set of smaller dimension tables. Okay, so here hierarchy is maintained. Okay, so when a dimensional hierarchy is normalized into a set of smaller dimension tables, forming a shape similar to a snowflake shape. Then fact constellation, multiple fact tables share common dimension tables. So here multiple fact tables, they share common dimension table, and which can be viewed as a collection of stars, therefore called as galaxy schema, or it is also called as fact constellation schema. So star schema, let us come to the star schema. The most common modeling paradigm is the star schema. Star schema is the most commonly used, in which data warehouse contains one large fact table. So here star schema contains, so it is shown in figure 4, we are having a star schema. So star schema contains a large central table called as fact table. So this is the central table that is called as a fact table containing a bulk of data with no redundancy. Redundancy is not present. So here sales is a fact table. So here what is present? So here fact table contains keys. For example, item key, time key, branch key, location key, dollars sold and units sold. So then a set of smaller attendant table called as dimension table. So these are all dimension tables. These are smaller attendant tables which are called as dimension tables. So one for each dimension. For every dimension will have one table, and that table is called as a dimension table. So item will have a dimension table, will have a time, for time we have a dimension table, for branch we have a dimension table, for location we have a dimension table. So if you want to access dimension table, for item you need to access item key. So if you want to access dimension table for time, you need to access time key. If you want to access branch dimension, you require branch key. Then if you want to access location dimension table, then you require a location key, and all these are a part of fact table. The schema graph resembles a starburst. So why this is called as a star schema? Because this star schema resembles a star face with the dimension displayed in a radial pattern around the fact table. Okay, so that only I told. The most common paradigm is the star schema, in which data warehouse contains one central fact table containing a bulk of data with no redundancy and a set of smaller redundant tables, one for each dimension. Okay, the graph resembles a starburst with dimension table displayed in radial pattern around the central fact table. So here the figure 4 shows the star schema for all electronics sales. Sales are considered along 4 dimensions. Sales. So here fact table is having a sales, and it is considered along 4 dimensions with respect to the time, item, branch and location. The schema contains the central fact tables for the sales. What it contains? It contains the central fact table for sales that contains key for each of the 4 dimensions. That only I told. To access dimension table, I require item table, I require item key. To access time, I require time key. To access a branch, I require a branch key, and to access location, I require a location key. And all these are the part of the fact table. Now we have 2 measures. So along with this time key, item key, branch key and location key, we have 2 more measures called as dollars sold and units sold. So this will give you how many dollars of sales has happened during a particular time, and how many number of units are being sold during a particular month or a particular year or a particular week or a particular day. To minimize the size of the fact table, dimension key identifiers, that is, okay, so these are all system generated identifiers. The item key and the time key, the branch key, location key, all these are, okay, so all these are things are system generated identifiers. Okay, so then notice that in the star schema, for each dimension is represented by only one table. So each dimension table is represented by only one table, and each table contains a set of attributes. Now here you can see each dimension table contains a set of attributes. So item dimension table contains item key, item name, brand, type and supply type. For a time key, day, week, month, quarter and year. For branch, name and type. And for location, street, city, province or state and country. For example, the location dimension table contains the location attribute set. That is only the location, street, city, province and country. This constraint may introduce some redundancy. For example, let us take one example of Urbana and Chicago are both the cities in the state of Illinois, USA. Entries for such cities in the location dimension table will create a redundancy among the attribute of the state and country, that is Urbana and USA, and Chicago is also in USA. Moreover, the attribute with the dimension table may form either a hierarchy or a lattice partial order. Next, coming to the snowflake schema. Snowflake schema is a variant of star schema model where some dimension tables are normalized, thereby further splitting the data into additional tables. So here the dimension tables are normalized where we have further splitting the data into additional tables. The resulting schema graph forms a shape similar to a snowflake. Okay, so the major difference between, so now coming to the figures of snowflake schema. Now what is the major difference between the snowflake schema and the star schema? Okay, so the major difference between the snowflake schema and star schema model is that dimension tables of snowflake model may be kept in normalized form to reduce the redundancies. So here, in order to, as in star schema, there are some redundancies with respect to the location we discussed. So in order to reduce the redundancies, okay, so the dimension tables in a snowflake model are kept in normalized form. Such a table is easy to maintain and saves storage space. However, this space saving is negligible in comparison to the typical magnitude of the fact table. Furthermore, the snowflake structure can reduce the effectiveness of browsing. So what is the limitation of snowflake structure? So it can reduce the effectiveness of the browsing, since more joins will be needed to execute a query. So you can see, so more number of connections are present in between the dimension tables and the fact tables. So the amount of time and the joins will be more. So in order to execute a particular tree, we need to go for multiple joins, we need to execute multiple stages of the query. So this will reduce the effectiveness of the system. Consequently, the system performance may be adversely impacted. System performance may be also impacted. Hence, although the snowflake schema reduces redundancy, it is not as popular as star schema in data warehouse design. So let us see in figure 5. In figure 5, snowflake schema. So this is a snowflake schema for all electronic cells in a as shown in figure. Here, the sales fact table. So the sales fact table is similar to that of the star schema. So which again contains the time key, item key, branch key, location key, dollar sold and unit sold. So what is the main difference between the two schema is in the definition of dimension table. So here, dimension tables are defined in a different way. The single dimension table for item in the star schema is normalized in the snowflake schema, resulting in a new item and supplier table. So you can see item. So item table is now is normalized into two parts. So in item, we are having item key, item name, brand, type and supplier key. So now here one more thing is added, the supplier key is added, because in a dimension table for item, we are not only taking into item, we are also considering the supplier and what is the type of supplier. Okay, so here also if we can go for the location is also normalized. Okay, so location table, dimension table, location key, street and city key, again city, prominence state, which is again, location is again normalized into city dimension table. So that is a single dimension table for location in the star schema can be normalized into two new tables, location and city. The city key in the new location table, the city key in the new location table links to the city dimensions. Notice that when desirable, further normalization can be performed on province or state and country in the snowflake schema as in shown in figure. So this is a snowflake schema. So this is similar to the star schema, but only thing is we have normalized some of the dimension tables. So one dimensional table is further normalized. For example, item dimension table is further normalized to the supplier table, and location table is again further normalized to the city table. Next, coming to the fact constellation. Sophisticated. So fact constellation, which is again represents a type of galaxy structure. So sophisticated application may require multiple fact tables to share dimension table. So this kind of schema can be viewed as a collection of stars, and hence it is called as a galaxy schema or fact constellation. Okay, so let us see the figure 6, which represents the facts constellation schema of a sales and shipping data warehouse. Now here what? So here again the fact table remains the same. So fact table for sales table, that is time key, item key, branch key, location key, dollars sold and units sold. So now here dimension table for item. Then we have added one more thing called as shipping and the shipper. Okay, a fact constellation schema is shown in the figure 6. This schema specifies two fact tables. One is sales and shipping. So now in this schema we have two fact tables. One fact table is related to the sales and another fact table is related to the shipping. The sales table definition is identical to that of the star schema, whatever we discussed. The shipping table have 5 dimensions. Now shipping fact table is having 5 dimensions or keys, that is the item key, the time key and supplier key, from location to location, and dollars cost and units shipped. A fact constellation schema allows dimension table to be shared between the fact table. Now what is the advantage? What is the difference over here? A fact constellation schema allows dimension table to be shared between the fact table. For example, here the item dimension table, okay, for time, item and location are shared between the sales and shipping fact table. So now which table is being shared? So item table is shared, time table is shared and location table is shared between the sales and the fact table. So you have the two fact tables and we require only one dimension table. No need to create separate dimension table for shipping and separate dimension table for sales. The same dimension tables for time, item, location are shared between the shipping fact table and the sales fact table. Okay, in a data warehousing, there is a distinction between a data warehouse and a data mart. A data warehouse collects information about the subject that spans the entire organization. A data warehouse, what it does? A data warehouse collects information about subjects that span the entire organization, such as customers, items, sales, assets and personnel, and thus its scope is enterprise wide. For a data warehouse, the facts constellation schema is commonly used. So for data warehouse development, a fact constellation is normally used since it can model multiple interrelated subjects. Whereas a data mart on the other hand is a department subsets of the data warehouse that focuses on selected subjects. A data mart is what? It focuses on selected subjects, and thus its scope is department wise. For data marts, the star and snowflake schema is commonly used since both are geared towards modeling single subjects, although the star schema is more popular and efficient. For data warehouse development, we are using the fact constellation schema, whereas for the development of the star schema, we are using either star or snowflake schema. Out of the star and snowflake schema, the most commonly used or the most popular schema is the star schema. Next, coming to the dimensions. So the role of concept hierarchies. A concept hierarchy defines a sequence of mappings from a set of low-level concepts to a high-level or more general concepts. Dimensions. What it is a concept of hierarchy? A concept of hierarchy defines a sequence of mapping from a set of low-level concepts to high-level or more general concept. Consider a concept hierarchy for the dimension location. Consider an example. Consider a concept hierarchy for dimension location. City values for location include, consider we have 4 cities, one is Vancouver, Toronto, New York and Chicago. Each city, however, can be mapped to the province or state to which it belongs. For example, suppose that the dimension location is described by the attributes number, street, city, province, state, zip code and the country. Okay, so these attributes are related by a total ordering format or the total order forming a concept hierarchy, such as, what is a concept hierarchy? Street to the city, city to the province or state or to the country. Okay, so this is shown in the figure 7. So in figure 7, what we have done? So now you take the concept of hierarchy over here. So what is an hierarchy level maintained? Now you take the location is one parameter. So now you consider all. If I take all these things into the consideration, then all the countries across the globe will come into consideration. So here I am taking only 2 cities. One is Canada, and we are taking only 2 countries. One is Canada and another is USA. So this is a concept hierarchy for location. So now I am taking all. So in that all the countries will come into consideration. Now I am taking only Canada and USA, 2 countries. So in between dots are there. So means multiple countries are there. We are taking only Canada and USA. So now coming to the province or state. So now Canada I am taking 2 states. One is British Columbia and one is Ontario. Multiple are there. We are taking only 2 states. One is British Columbia and one is Ontario. Whereas USA, I am taking 2 states. One is New York and one more is Illinois. Now this is a hierarchy. From all over the world to the country, country to the state. Now state to the city. Now in British Columbia we have 2 cities covered. One is Vancouver and one more is Victoria. For Ontario I am taking 2 cities, only Toronto and Ottawa. For New York I am taking New York and Buffalo. For Illinois I am taking Chicago and Urbana. So this Vancouver again, the city can be under further further can be divided into the area wise. Street. Okay, so city to the street, and the zip codes can also be added. Okay, so now this is another example, concept of hierarchy for location indicated by the ellipse between the nodes. Now the concept of hierarchy for location indicated by ellipses between the nodes. So now what we are doing over here? Now country to the state, to the city, to the street. Now second one, this is with respect to the location, and this one, this is with respect to the time, lattice time. So year to the quarter, quarter to the month, month to the day, or you can have day, week or year relationship, or you can have day to month, month to quarter, or quarter to year. So this is a level of hierarchy. So in a year you will contain all the data that sold. Consider you are considering the sales data in a 1 year. So complete year, complete data, complete sales in 1 year. Now this node will give you the complete sales in a particular quarter, in particular 3 months. In particular 1 month if you want, I will get all the data over here. Now if you take a particular day, how many sales have happened in 1 day will be covering into this part. Okay, so this is how the concept of hierarchies. So there may be more than one concept hierarchy for a given attribute or dimension based on the different user's viewpoint. For instance, a user may refer to organized price by different stages for inexpensive, moderately priced and expensive. Concept hierarchies may be provided manually by system users, domain experts or knowledge engineers, or may be automatically generated based on the statistical analysis of the data distribution. The automatic generation of concept hierarchy is what we have discussed up till now. So in this video lecture we have studied in detail different schemas for multidimensional data models, and we discussed 3 different data models in detail. One is star, snowflake and fact constellation. What are their advantages and where they are used? So fact constellation or galaxy type of structure is preferred by the data warehouse, whereas the star or the snowflake schema is referred or preferred by the data mart, whereas out of star and snowflake star schema is more commonly used. Then we seek to the concept of dimensions, the role of concept hierarchies. We saw the 2 examples. One is the concept of hierarchy for location, and the concept of hierarchies for a time also we have discussed in this video lecture. So now this is I think it's more than enough for this video lecture. In the next video lecture, in the last video lecture, we will discuss the major, their categorization and computation, and the last point what we call as typical OLAP operations. So with this I conclude the video lecture on different schemas for multidimensional data models, where we cover the star schema, snowflake schema of a sales data warehouse. So we took examples of star schema for sales data warehouse, snowflake schema for sales data warehouse, and fact constellation table schema for sales and shipping data warehouse. So multiple methods, multiple datas we have studied, multiple models we have studied. So then concept of hierarchies we have studied. So in the next video lecture I will be covering the measures, the categorization and the typical Veilab operations. So thank you one and all.